Welcome to the Tech Egg. Don't get scrambled. Enjoy the video.
You start by creating a clean Python virtualenv and installing OpenCV, dlib, face recognition, numpy, and immutals. Then, organize labeled folders for each person with 1 to 5 varied images each so models learn pose and lighting. Next, write a small script to load images, detect faces, and compute 128 8D embeddings using face recognition. Face encodings. Once done, save embeddings and labels to disk as a serialized dictionary, or CSV, so you can iterate quickly in later steps. Now build the recognition pipeline. Load saved embeddings and train a KNN or SVM classifier on the 128D vectors. KNN is fast for few identities, SVM scales better. Implement real-time capture with CV2. Video capture, convert frames to RGB, and call face locations and face encodings each frame. For matching, compute Euclidean distance and apply a threshold 0.6 typical, or use nearest neighbor voting across multiple frames. Make sure to throttle detection frequency for performance and cache recent results to smooth jitter. To finish, wrap the inference into a Flask or Fast API endpoint or a lightweight desktop app so you can send frames and get identities back. Optimize by resizing frames to half, batching encodings, and enabling GPU-accelerated dlib where available. Once done, test on live feeds at different distances. If you hit poor accuracy, increase per-person images, include different lighting and angles, and tweak the distance threshold or retrain your classifier. One troubleshooting tip. If false positives persist, raise the threshold slightly and add negative samples.
Thanks for watching. Consider subscribing if I helped unscramble your problems.